Hello everyone, I am Manish Singh. Today I am going to talk about speech language identification on behalf of my team. Before I begin, a special thanks from our team to Wiley team and IIT Mandi for this wonderful opportunity. First, what exactly spoken identification means? Well, on the basis of the words, you can get that it is a process in which we will recognize the language based on its spoken utterances. In more simpler words, I can say that it deals with classifying the language based on speech recording. The possible application scenarios involves digital law enforcement, emergency call routing, spoken document retrieval, and much more related to such things. In the current domain, we are going to use deep neural network. Well, the key thing to make your machine learn is one and only dataset. Here we are going to use IIT Mandi Read Speech dataset. Basically, we are going to make our machine learn to recognize 4 Indian languages, and in each language there are around 15 speakers, which means that we will take input of 15 different person for the same language. Now we will pre-process our data to transform raw data into efficient format. To do that, we will remove the background noises from our audio files. We will make our audio signal in such segments that we can achieve stationary signal for better differentiation. After it, we will be converting those signal to frequency domain using Fourier transform. This is how we are going to pre-process our data sets. Now let's move on to approach. We make use of acoustic model for identifying 4 Indian language. We have divided our approach in 4 steps. First, preparing audio data for deep learning model. How we are going to prepare our data for it? First, first of all, there is pre-processing of audio data. We have already spoken about it that we are going to remove the background noise, and we are going to make our signal in such a way that we can differentiate one signal with another signal. Now our data set will be in efficient format, so we will produce MEL spectrogram using Fourier transform to decompose any signal into its constituent frequencies. These frequencies will wrapping will allow us a better representation of sound in audio compression. After it, we will select a compressed representation of frequency band from MEL spectrogram. After preparing the audio data for deep learning model, we will design our model for it. We can train our model in 2 different ways. We, we will build CNN classifier to predict target class probability given on the basis of MEL spectrogram image. And also we can build FCN classifier to predict target class probability given on the basis of MEL's frequency septal coefficient. As the model is trained, hyperparameter tuning will be used. The ultimate goal of hyperparameter is to find an optimal combination of hyperparameters that minimize a predefined loss function to give a better result. In the end, we will compare the accuracy and we will analyze the result of CNN classifier and FCN classifier. We will come to conclusion at the end that which of them are more accurate than another one. Now here we are going to discuss our planning. Here we have shown the timeline that we are going to use or we are going to follow in order to accomplish our project. In the week 1, we will gather all the resources regarding our project. In week 2, preprocessing of dataset and feature extraction will be done. In week 3 and 4, we will design and implement our deep neural network. And in week 4 and 5, we will study our performance of the CNN and FCN classifier. We will compare the accuracy of both of them. We will come to a result and we will compare both of them, that that from this which of it is more accurate. After planning, we are going to talk about role. Well, talking about the role, here in our team, everyone is cooperating with each other and we are learning all things together. Still, we have given roles to everyone as everyone is having a equal responsibility in the in the project. Here Saroj Kumar is as a leader in our project. I hope you will like this. Thank you very much.